So this is an example of I said that two-channel transistor that I mentioned before. It's basically a 200 watt, but it's based on two independent 120 watt channels. So this gets back to, I mean, you can do push-pull type amplifier designs with this, or just from that swap analysis that I mentioned. You know, if you had two single 120 watt transistors, that's going to take up more space than a two-channel single package. So again, that allows a smaller form factor on the board for that power level. So good performance, a lot of flexibility with this type of package.
This is CW output power or pulse?
No, this is pulsed.
Pulse.
Yeah. Yeah, and these parts are on our website, so you can see it. You can see it better on the data sheets. But this is pulse performance.
It can use wide pulse wise.
Well, you can use a wider pulse. You can you can go up to CW if you want to, but then you have to play around with the thermal trades as well as, so the performance is going to come down versus what you see here. So it's just a trade-off. You won't be able to run it at a higher as high as voltage. You'll have to drop the bias down to manage the thermals if you go CW.
But the voltage only can use 36.
Yeah, so 36 volts at pulsed. If you run it,
use
if you run it,
48.
Well, it comes to a thermal management trade-off. So we recommend on this product at 36 volts for proper thermal management. So if you go to CW, you'll need to probably drop it even further. Okay, so I'm going to move up to X-band radar. Again, a lot of activity in X-band radar. So you can see here, I'll touch on our gallium arsenide portfolio. We have a lot of gallium arsenide products, basically 16 watts and below. A lot of our new development is primarily gallium nitride for X-band. So you can see there's a lot of interest from 9 to 10 for weather and marine radar applications. So you can see, again, like I mentioned, we have kind of a standard 2-watt driver, but then we have a family of gallium nitride products in the 9 to 10 band, 18 watts, 40 watts. These two are mimic products. These two and these two are currently what we call under commodity jurisdiction review. So that's basically we send the request into the government to get their official decision on export controls. So our push is commercialization of those products because there's plenty of commercial activity for this product, but we'll see what they come back with, what export control license they come back with. But again, that's a weather marine radar, good performance, 18, 40 watts. These are in the 35-40% efficiency range. These are mimic products. If we move up to the 2312 and 3002, those are hybrid PAs. Those are single stage gallium nitride hybrid PAs. So 60 watts and it's released now, and 100 watts will be released here in the next couple of months. So again, with efficiencies probably, efficiencies here in the 40% range, and efficiencies here will be targeting about 40%. We have this 2238, which will be an ITAR product because of the wide bandwidth. The X-band is somewhat sensitive for the Department of Defense. So the wider you go in X-band, the more restrictive the export will be. So the 2238 will be an ITAR product, but at 50 watts, 40% greater than 40% efficiency, this is a world-class performance for that band. A lot of excitement behind that part. That's specifically for radar. We have this 2590, which was developed for electronic warfare, 6 to 12 electronic warfare. So I don't see this. This is also an ITAR part because of the wide band. I don't see this being really used for radar going forward with the 2238 coming available.
Currently, you haven't ECC encoder for those parts.
Right. So our gallium arsenide, we have a mixture of ITAR and 3A products. These four are still under review. So we're hopefully in the next couple of weeks we'll hear back from the Department of State on what the export controls will be. The 2590 is ITAR, 2238 is ITAR, and these two, well, the 2312 is a 3A product, so we can export that, and the 3002 will go through the same. We'll go through the same review process with the government to determine that.
So are those power levels pulsed or CW? Are those in this way?
It varies. The 30 watts is CW. Everything else is pulsed. So that's targeting our radar amplifiers. As I said, most of it's gallium nitride development. We are developing the complete chipset, like I mentioned. We already have a lot of the RF functionality already in our portfolio, but we're also developing higher performance variants of that. The switches, like I mentioned, we have our switch development is primarily gallium nitride based today. So we have upwards of 100 watts of switch, and I'll have another slide on that switch. But up to 6 gigahertz, and then as you go up to 18 gigahertz, we start dropping it in power handling. But again, orders of magnitude above what gallium arsenide switches can handle. We do plan future development. These are all single pole, double throw. We plan 3-throw and 4-throw switches as well at these types of power levels. Limiters, we've been supporting a 5-watt limiter for 15-20 years. We've recently released upwards of 100-watt limiting capability, really targeting ALS and C-band type radars.
CW power or power?
The 100 watts is, well, it's both, but at 25C temperature. If you drop it down, if you increase the temperature up to 85C, that drops to about 30 to 70 watts, depending on the part. We have multiple parts there. Attenuators, again, you don't want to spend a lot of money on attenuators. You don't want to use a lot of board space for attenuators. We're coming out with best-in-class performance, very small size control functions to support both the attenuators and the phase shifter product line.
It's also use GaN technology?
No, the attenuator, well, the limiters are gas V-pin. Attenuators is gallium arsenide, p-hemp. So we have an analog attenuator that's currently in development, and a digital step attenuator that's also currently in development. And I'll have another slide on the DSA in a second. And then phase shifters, we released last year a 6-bit phase shifter, best-in-class performance in the market, covers 6 to 18. The 6 bits obviously gives you that higher resolution that the systems are requiring today. And then we have a 2 to 6 that's targeted for development. Now the benefit of these wideband products is, as I mentioned earlier, a lot of the electronic warfare systems are starting to look a lot like radar systems. So electronic warfare obviously inherently wideband. So a lot of these wideband attenuators, phase shifters can also support the electronic warfare systems as well. And then we have LNAs, as I mentioned. We still have some gas LNA work being developed. We recently released 2 GaN LNAs, a 2 to 6 and a 6 to 12 GaN LNA. The benefit here, like I mentioned earlier, is the robustness. Potentially eliminate the need for the limiter, which increases even more so your system reduces your system noise figure if you can get rid of the limiter. And then we have another wideband GaN LNA that's currently in development.
Do you have this switch driver?
We don't.
Demo board.
We don't have the drivers associated that's for these switches. So we are doing other. So these switches, as they're offered today, are require 40-volt controls.
Minus 40.
Right. We have some development, actually some recent development that we just finished up, that actually is taking that minus 40 volt and dropping it down to minus 10 to minus 15 volts. So much easily handled at those, but we won't offer that variant until later in the year once we productize it. But we did some development, and we're getting very good performance at minus 10, minus 15 volts. So this is an example of the 100-watt switch, TGS 2355 SM. We're actually working the data sheet now for the 5x5 QFN. But again, good. It achieves 100 watts pulse condition. Then this is 0.1 dB type compression points at the lower frequencies, and then it's about an 80 watt switch, 0.1 dB compressed at the higher frequencies. A lot of excitement behind this particular product. But again, targets the primary, the LS and C band radars, instrumentation, communications, and just general purpose switching. We will have data sheets, eval boards, things of that nature for this product here this month of June.
You will be also not include the driver.
Right now we don't offer the drivers for this. And the good thing about the GAN switch compared to a pin switch or something like that, very low control current, so very little prime power is needed from the system for the GAN switches. So high power handling, small footprint, very low power consumption. So this is one of the high power limiters. This is the broadest band limiter, 1 to 6 gigahertz. So targets all the LS and C band radars. But good insertion loss at half a dB of insertion loss. Power handling at 50 watts at temperature. You can see good flat insertion loss. Up actually beyond 6.5 gigahertz. Good limiting performance. So the flat leakage is less than 16 dBm. So protects that LNA quite nicely with those high incident powers. Small package of 4x4 air cavity ceramic.
How about the leakage? 16 dBm.
Yeah, 16 dBm spike leakage. Well, actually, the flat and the spike leakage, I think, is one. I want to say maybe 16.5. It's just about half a dB. So this is a snapshot of our 2611 GAN LNA from 2 to 6 gigahertz. Again, we're offering that in a plastic overmold QFN 4x4. So good P1 dB numbers at 22. Good gain at mid 20s for gain. Noise figure, nice noise figure at a dB across most of the band. You get flat P1 dB across the band, so very good performance. The bias condition for the GAN LNAs is running about 10 volts for both the 2 to 6 and the 6 to 12. But again, good noise figure. The input robustness is about 2 watts, so you can hit it with 2 watts without degrading performance. Compare that to a gallium arsenide PA, which would be on the orders of milliwatts.
Do you have the ceramic package?
This is plastic.
Yes, it's plastic.
Yeah.
Do you have ceramic?
No. No. We wanted to keep this as low cost as possible, so we designed it for plastic. We have plastic capability in-house to TriQuint, so all this is done in-house. Plastic packaging is done in-house. So I'll state when I was reviewing these slides this morning, these graphs are the same graph as the previous slide. So, but actually you can imagine these curves shifting up about a dB is about what the 6 to 12 will do. So I'll correct that on the presentation that Aero puts on their website. But again, good 6 to 12 performance. Again, mid 20s for gain, lower 20s for P1 dB. Noise figure is about a dB and a half for the 6 to 12. Again, these are the wrong graphs. You need to shift these lines up about a dB and a half. But good solid performance across the 6 to 12, really targeting X-band radar as well as a variety of communication bands that covers that. Example of the 6 to 18 phase shifter. This is the 2105. positive control voltage. Again, across this band, 6 bits. You won't find anything else in the market that performs as well as this part does, with less than 10 dB of insertion loss, RMS phase error in the over that 6 to 18 band is basically 6 degrees or better. EAR99, so it's easily exportable. So, very good performance. Amplitude error, less than a half a dB amplitude error.
That means the customer also can buy the die.
Yeah. So we offer it in both die and package. So the package is a 5x5 air cavity ceramic. So.